So this is a review for going over modifying lists and dictionaries using pop and delete notation. So for each color, we want to capitalize each color without using dot capitalize. So we want to use this method down here using character and ordinate. But if we use character and ordinate, we can't use slicing. So either way, we're screwed because my professor is living in the 70s, apparently. If we delete or pop these values, they'll be gone. As you can see here, we deleted the values. dname is delete dname. That's how we got the empty set. So we need, if we want to capitalize colors, for color in the values. Red, blue, yellow. So for color in list, what are we going to do to each color? the question isn't really so much as what we're going to do to each color, is what we're going to do to each variable. I guess it's for each color. So like here, we said if the name is lowercase for I in range length of the name to a different list, we are appending the uppercase version. So we didn't edit it, we just made a new list with the uppercase version. So we can do that here too. And just that new list is color list. So I can just copy and paste this code. For I, it'll be a little different. It'll still use slicing though, which is a problem. For I in the length of the color, I'll do for character. Change this to so what does this actually do? For I in range length name, saying upper name list, insert so this really isn't necessary because we use slicing. This just creates a new string. It doesn't reference I, it just references that character. Upper name, insert that character. So this is not being used right now. So up here, it would be the same. For color in list, we would do color list. Insert color (0 minus 32) plus color 1 to 1. So like if color is equal to red, color equals red, then new equals color (0) character coordinate color 0 minus 32 plus color -1 to -1. Or we can just say to the end. So we don't need this -1. And that is how we would uppercase red. Again, we use slicing, which is typically not allowed. You may not use any string method. Is lower, is upper. Those are string methods. There's no other way to determine if it's upper or lower. Unless it's like a Unicode value of certain number. So like ordinate of A (97). Is that really where it starts? Like, what is character at 0? It's character 0. So A is 97, which means uppercase A comes first. So ordinate of uppercase A is 65. So instead of saying is lower, we can say if name 0, if ordinate name 0 is let's do minus 65, because then we just have the alphabet. So ordinate name 0 minus 65. Modulo 2, because we want to see if it's even or odd, right? Actually, no, we want to see if it's less than, I think there's what, 27 in the alphabet? Because if we subtract 65 from here, we get 32. 65, we would get 32. So what is ordinate 32? Character 32, because I know there's not 32 letters in the alphabet. Character 32, it's a space. So we can honestly just use a comparator. So we know the alphabet starts at 65. So if ordinate name is minus 65 is between because 65 is A. So it can equal 65. But the max is less than or equal to, not 32. I think there's 27 in the alphabet. So let's try character 27. No, character 26. Oh my gosh, I'm gonna like sing the ABCs in a second. 24. A B C D E F G H I J K L M N O P Q R S T U V W X Y Z. That's 26. Oh, so it would be 26 plus 65 is 91. Character 91. Character 90. Okay, so character 90 is Z. So that's another way of saying is lower, basically, if you're using Unicode. You say if that digit is minus 65, is between those two values. Or if we just pull up a Unicode chart, for Python, here we go. Lowercase English is 97 through 122. So we can get rid of this and just say 97 and 122. Okay, another way of doing it. So this is saying if it's lowercase. So instead of saying is upper, we'll just put the range of values for uppercase Unicode characters, which is 65 through 90. So 90, 65. Here we have our formatting. without using string values, because I still want to follow like the instructions on the interpreters. Oh, I'm sorry, not the interpreter. The guide here. So as you can see, it still works. We would just subtract 32 to lowercase, to uppercase. Back to up here. So for character, again, this is not being used. We may need to use it if we want to get rid of string formatting, slice formatting. So, so we have our list of colors. What do we do after we have our list of colors? We want to add it to the dictionary now that they're capitalized. So here, for name and dictionary, for list and devalues. So list and value. For color and list, insert that color to our color list. So it'll be our color list right now. If for our first is red, blue, yellow. So after we do that, so we have red, blue, yellow. Then for list and devalues, so we're still in that first list. So for I in, or let's say, so for name in our dictionary name equals list color list. I don't think this will. For name and dictionary. Dictionary name, so George equals color list. This is for like each list. So we go on this first list. Color. Insert these capital colors to our color list. And then for name in dictionary, so George. Then George is equal to color list. We'll say if dname equals list. So we're matching the values. So if it matches, then we update it. We're saying if for each name, so George, if the value is equal to the list, which for list and values, this would be the first one would be red, blue, yellow. If there's another red, blue, yellow, it would update that one too. So it might update a couple times, but the value would still be the same. Dname is equal to list. Red, blue, yellow. So if the value is equal to our list, then update that value with color list equals color list. And then we are going to clear color list so that for the next name, or for the next list, doesn't keep the previous colors. So we're going to so we go back to color list equals empty list. So if we review set colors, color list is empty for each list and values. So boom, for color and list, insert that color but capitalized into color list. For name in dictionary, if the value is equal to list, which is true for this one, then dname is equal to color list. Else pass, and this pass statement would return us back to our for loop. So this is saying for name in dictionary, if it equals the color list, or if name is equal to list, which it is, then update it with color list. So it would be all capitalized, the same list but capitalized. And then we clear the color list and go to the next name. So we actually don't want this here. We want this outside for color in list, because we want to test every name for name, because after the first name, so for name in dictionary, if this is equal to the list, update the list. Else, so for name in dictionary, if dname is equal to list, dname equals color list. Else if dname is not equal to list, then we pass. Which means we go to the next. That means we go to the next name. this is actually unnecessary. I mean, we can explicitly say this, or we can just say else. I'm just gonna say else to save on space. I'm gonna go ahead and plug in my charger here. So don't get cut out. Oh boy. I did plug in my PC. Load. Oh, is this not right? I guess this is not the right power. Here we go. That's the right one. Alright, I'm going to cut this one off.